Hello everyone, my name is Nurfata binti Muhammad Nurhan. Today we are presenting the application of metric in the real life in subject AD 3013 from K1 and our group from group 10, and our lecturer is Dr. Nurafida binti Afrizal. Okay, next. This is our group members. First, Muhammad Nizam bin Razali. Second, Muhammad Fatihin bin Ibrahim. Nur Anis Ayuni binti Haz. Izanur Husna binti Mio Arizimi. Dan yang last sekali itu Nur Fatah bin. And the last one is Nur Fatah binti Muhammad Nurhan. Okay, today we will discuss the intro. First, we will discuss introduction matrix, history. Three is application for the example, and the last one is the reference.
The matrices are a two-dimensional set of numbers or symbols distributed in a rectangular shape in vertical and horizontal lines, so that their elements are arranged in rows and columns. They are useful for describing systems of linear or differential equation, as well as representing a linear application. Every matrix is represented by a capitalist letter, and its elements are given in lowercase letters in a list enclosed by parentheses or square brackets. Each, in turn, has a double superscript. The first refers to the row and the second to the column to which it belongs.
History of matrix. The history matrix goes back to ancient times, but the term matrix was not applied to the concept until 1850. Matrix is the Latin word for worm, and it retains that sense in English. It can also mean more generally any place in which something is formed or produced. The origins of mathematical matrix lie with the study of system of simultaneous linear equations. An important Chinese text from between 300 BC and AD 200. Nine chapters of the mathematical art, Qiu Shang Xuan Shu, give the first known example of the use of metric methods to solve simultaneous equations. Since their first appearance in ancient China, metrics have remained important mathematical tools. Historically, it was not the matrix but a certain number associated with a square array of numbers called the determinant that was first recognized. Only gradually did the idea of the matrix as an algebraic entity emerge. The term matrix was introduced by the 19th century English mathematician James Sylvester, but it was his friend, the mathematician Arthur Cayley, who developed the algebraic aspect of matrix in two papers in the 1850s. Cayley first applied them to the study of system of linear equations. Where they are still very useful, they are also important because, as Cayley recognized certain sets of matrices from algebraic system in which many of the ordinary laws of arithmetic, example the associative and distributive laws, are valid, but which other laws, example the commutative law, are not valid. Today, they are used not simply for solving system of simultaneous linear equations, but also for describing the quantum mechanics of atomic structure, design computer game graphics, analyzing relationships, and even plotting complicated dance steps.
Okay, we go further to application metric in real life. Matrices have many applications in diverse fields of science, commerce, and social science. Matrices are used in computer graphics, optics, cryptography, economics, chemistry, geology, robotics, animation, wireless communication, and signal processing. In this video, we will go details and focus on the application of matrices in computer graphics only. Earlier, architecture, cartoon, automation was done by hand drawings, but nowadays they are done by using computer graphics. In video gaming industry, matrices are major mathematical tool to construct and manipulate a realistic animation of a polygonal figure. Computer graphics software uses matrices to process linear transformations to translate images. For this purpose, square matrices are very easily represented like linear transformation objects. Matrices are used to project three-dimensional image into two-dimensional planes. In graphics, digital image is treated as a metric to be started with. The rows and the columns of metric correspond to rows and columns of pixels, and numerical entries correspond to the pixel color value.
From an application in computer graphics, we can give an example about matrix reflection. Reflection, also called mirroring, is a transformation that flips the object about a line in 2D or a plane in 3D. Matrix multiplication can be used to reflect a figure to flip across its line symmetry. The example given is only the axis coordinates and the predefined matrix. To flip over the axis, we have two multiple coordinates to this matrix axis, and so on as shown in this slide. In this case, the figure have to flip the x-axis, so we have to multiple the coordinates, which is 17, 1, 2, 6, 2 matrix, to x-axis matrix, which is 1, 0, 0, negative 1, and the answer is like in the slide, 1, negative 2, 1, negative 2, and 6, negative 2. So this is how computer graphics work to flip an object to be displayed on the screen.